Alright, let's take that out. I've got 2 CBN shoes. And like always, I unlaid them somewhere. It's a hardened shoe I haven't used yet. Here's one, I don't know which one it is. Like this right here. I've got 2 of them. One's a coarser grit than the other. Okay, this is a fine grit. It's not the one I use. It's got to be right here because I just used it on that other tube. Snakey bit me. Wish I had a nickel for every time I did that. I guess a lot of this is probably not even getting in the shot. Okay, I hit it with a truing stone, and that is basically, this is a blind hole. You're only going in one way. And the way I'm going to make sure that it is not bigger in one spot than the other is keeping this stone absolutely straight and true. The stone, as you can see, comes all the way down to the end, so we will be able to get all the way to the bottom of the tube. But I think at this point, I've been using this a little bit on that other tube, so what I need to do at this point is I need to dress this ever so slightly, and I use, and if I can find it here, this is a 220 grit CBN stone. And what I need to do is I just take another honing stone, preferably finer grit than 220, and yeah, here we go. This one's a 400 grit. And what I do is I just rub it on there, wipe it off, and that'll give me fresh cutting edges. You see that? See how it's jumping around? And I'll try and get some as I'm going through here, I'm going to show you where all the flat spots. Alright, if you look, you'll see it's cutting in the back of the tube. It's the tightest spot in the whole tube. I don't see the traditional, you see a little bit of the flats and everything, but if you look down in the bottom tube, it's not even touching. Down in the bottom of the tube. And as I start getting the back of it ground out to the point where it's all getting fairly even, then you'll start seeing the 3 flat spots kind of come up. See how this is? is getting, man, that thing gets hot. I can tell you it's see, just that little bit, that CBN, it cuts really fast. It'll peel it out even at 220 grit. I think the only two stones that they set that Sunnen sells is like a 220 grit and a 400 grit. Anyway, you can still see there's that flat spot. The 3 streaks you see running up through it are where the shoe and the stone was when I pulled it off of the mandrel. It's fairly smooth back there, but as you get to the front, you got jump real bad. Got around. And that thing gets hot. That's what you would call bell mount. At the very base, down in the bottom. And you won't get that bell mouth out until the entire rest of the tube has grown out. I should have took a measurement off this and showed you where it was. You can actually just take a pair of dial calipers and measure around the back, and you can see a slight out of roundness, usually in the back, but hot. I got some water right here. I keep dipping it in. Okay, we've got about 80% of it out. There's still one flat spot. Let's see if I can get this again. There we go. I don't know how much of that you're going to be able to see. You can see. Let me figure out where that flat spot is. Okay. At the bottom, you should be able to see it if I can get this light just right. See, this is what I hate about trying to get this stuff on camera. It is... Oh, there we go. I'm hoping it shows up. I can't tell just looking at the... but up near the transfer port, you can see a little bit of a flat spot still in there. But it's starting to look good. Yeah, I don't know if you could tell how slick that was. Ooh, it's almost there. One thing I do, it gets extremely slick when you get this thing honed right, and when you get all the way to the bottom, where the plug goes in the end of it, you'll be able to see a reflection of all the machine marks on the end plug in the walls. You won't see those dark spots where nothing reflects. That's basically how I do it. And I'm not trying to hit a particular size here. What I'm trying to do is get it perfectly round. If it's perfectly round, you can use a hard, like I said before previously, you can use a harder seal. You get a little bit more power. Having the parachute isn't as critical. And you also, when you button your piston, you can machine it all. You can fit your seal and everything same way you fit your buttons, have everything perfectly straight, and you don't have to worry about the seal being, the seal can move around a little bit from the factory, and if you got a tube that's not perfectly straight, it's got a parachute on it. It can move around on the piston. If you get that where you got a flat spot going off to one side, it can compensate some. It's never going to compensate for all of it. And you know what? This is the way it comes from the factory. There's people that shoot these things for thousands and thousands of rounds. What I'm doing here is I'm trying to optimize it, make it as efficient as I can get it. The way I typically set things up, I don't want to put the biggest, heaviest spring I can find in it. I want to make the components more efficient. If you're going to get some horsepower, get the horsepower you don't have to pay for with excessive cocking effort and heavy recoil and everything. If I can do this, and I can get what the factory gets and throw a spring in there that has like 8 pounds less cocking effort, the recoil will be down to almost nothing. You get them down to where they just don't recoil at all. That's why once this is done, you can throw a weaker spring in there and you'll get about factory velocity, and the gun will just shoot absolutely beautiful. Still got a little bit, see that right there? And you can tell it's a little bit tighter in the bottom now. I've done work the back of it down to the point I can start truing up where those flat spots are. Oh, man, it gets hot. Did I mention that? I'll flip it around. Move your stone straight. Still got a, well, I'm gonna be here a while. Last little bit doesn't want to come out. Okay. We still have, looking at the back of it, at 2 o'clock there's a flat spot that just hot, hot, hot. Oh man. All right. I don't know if you can see it, but at 12 o'clock, flat spot 12, and yeah, it's light is, and there's one at 6 o'clock. I think you can see that one. Flat spots at the very bottom of the tube. We are going to be here a while. This thing is getting, one of these flat spots don't want to go away. It's going to take a lot of work to get them out. At this point, the flat spot has moved back. It's not all the way near the end of the tube. And the one in the front, I'm hoping you can still see it. It's a flat spot down in the bottom. If I get one of these tubes where they're only about 2.5 thousandths or something like that, 2 to 2.5, I would have had it worked out by now. Getting blistering hot. So I don't know if you can tell how pink my hand's getting. Getting those last little bitty flat spots are the hardest part in here, because all the, when you start out, you're hitting all the high spots and you're knocking those off. As you get further and further along, if you're going to get rid of a flat spot in the bottom of a tube like that, at this point, all the metal has to be removed that isn't a flat spot in order to get it perfectly straight. And it takes a whole lot to get that final little, you got to remove the metal from the entire tube all the way down. I'll tell you right now, I'm going to have to invest in some carbide shoes. Keep doing these. It's easier to just quit doing these. Okay, I better. That sleeve, and you flip it around, that keeps that stone perfectly straight. And I got it way too much. Just feel it bumping that flat spot. But I mean, if you look back at the beginning of the video, you can see, just that right there, just listening to it, and the way it's moving back and forth, it's just really, really slick. Whew. Getting tired. We're getting there. There's just a couple, yeah. Still there. Oh, if this flat spot was near the back, I wouldn't be near as worried about it. One in the back wouldn't be near as detrimental to the performance as being in the front. I want the whole tube to be straight, but boy, I'll tell you that right there, that's getting slick. Oh, man. Fun never ends. wonder how many people would watch a video all the way to the end if all I did was stand here and hold on a tube for 2 or 3 hours. Might help some people get to sleep. What you got a couple flat spots down in there, and I guarantee you they're less than 1/1000th. But the problem is, before those flat spots go away, everything else, all the metal in this tube have to get down to that point. You have to remove 100%, all the metal that is perfectly flat and straight. You got to remove 1/1000th of that. That's 2/1000ths more that's got to come out of this whole tube. And this is really, I mentioned that in a previous video about hunting. When you start getting tubes that are out this bad, you don't, if you're trying to get it absolutely perfect, you could spend, just a long, long time, because this is not the way you need to be doing it. Preferably what I should do on this situation would be go ahead and get the end plug out of the tube and chuck this up, indicate it in, and run a tool post grinder with an extended shaft right out the bottom of it. The fact that it's, you're going to have to grind it out. It's either with this, which the CBN will peel a lot of material off real fast, but when this tube gets to the point that it's mostly straight, then it is just, you're not just removing those, you're not removing a couple little flat spots, you're not removing 1/1000ths down there. You've got the entire length of the tube has to be drawn out. And this is just not the best way to do this, but it's the tool that I have. It does an absolutely beautiful job, but this is asking a bit much for this type of hardware. You start removing that much metal over the whole length of the tube. When I first started honing on this, one thing that was hot was right here in the back, because that's all you were removing was right back here, so you could open up. I mean, the entire front of the tube was completely, like I said, about 3/1000ths larger than the rest of the tube. At this point, I don't, when I get frustrated with something and that's hard to do, and I'm sitting here burning my hands up, I start trying to think of some other option. I've got some really, really soft stones that are silicon carbide. On hard, it's just like selecting a wheel on a surface grinder. You gotta, really hard materials, you gotta use softer stone. If you gotta really soft material, you want to run a harder stone. Anyway, I just switched out to a silicon carbide. It's a really soft stone. These stones don't last long, but see, you can hear it hit that. My dad used to, we used to do his oil field business, carbide balls and seats, or check valves and oil pumps and everything. And anyway, he had a tool post grinder, and he'd set it up on a lathe, and he would grind on those carbide seats where they would get kind of beat up on the face, and you do one side, flip it over, and grind down the other side, and they would come out of the chuck of the lathe where he was grinding them, and he'd set them on a board next to the lathe on a little cart. And I would be doing the grinding on the seats. I did the seats. He pretty much did the balls. anyway, he would walk over, he'd look at it, he'd say, how's it going? He reached down there and he'd pick up one of those seats that I had he couldn't tell which side was where I'd just been grinding. And he'd grab one that was still hot. He'd pick it up and he'd go, and he'd throw it down real quick. And I said, is it hot? He said, no, it just didn't take me long to look at it. I'm going to tell you right now, this thing is hot. It has nothing to do with how long it takes me to look at it. You see how it starts moving real free. That's because this stone is breaking down really, really fast. It's hot. Man, it's hot. Sticks when it gets down the bottom of that tube. I think it's working though. These are the size on these stones. It's not like surface grinder stones. The hardness goes by the number. And Sunnen's honing stones, you'll have like let's see, these are a 95, and it's extremely soft. You see me constantly having to turn it up to take up because they wear down really, really fast. Matter of fact, this stone was fairly new. When I put it in there, it's almost gone. There's very little material left on it. By the time I finish with this tube, that stone will get thrown away. A 99 J, they have A or J. J is a this is an 85. J is silicon carbide. A is aluminum oxide. This is a J, and it's a 95, which is a 500 grit. But the 95, I've also got J99 somewhere in this pile. J99 is a 500 grit also, but it's a lot. The bonding material in it is a lot harder. So if you got a soft material, the J99, it's like the receivers on a barrel cocking gun or something like that. They're typically not. They're not hardened. The steel's much softer. It's not even an alloy steel. It's just a low carbon steel. And sometimes the J stones give you a little bit better finish. These are extremely soft. Like I said, just me doing this one tube. I can't see. I'm gonna have to let it get dry and look down in the bottom or clean it. But 95 is softer than 99. And I have to look and see how they all break down. I've got the 150 grits. I have 47 and I believe 59. I don't have a whole lot of them laying right here right now. Yeah, 49. This is a R28A49, so it's aluminum oxide 49, and it has 01 at the end of it. That means that you can't really tell real good from there, but the tip of it's harder than the back side of it. No, this is the tip right here. You can see the line. I don't know if you can see that line in there or not, but the tip is harder than the back, and these are specifically for doing blind holes, so the tip won't break down. Before that, a lot of people would relieve the side of the stone back here, so it wouldn't. So this would break down faster, and the tip would last longer. Because what you have problems with when you do blind holes is that it gets tapered as it goes to the front, because you can't get enough oil and everything to keep it. I dress my stones real regular, and that's ultimately how you have to do it, even if you're using a hard tip stone. But anyway, but getting back to these are 59. These are really hard. If there's a imperfection in the bottom of the tube, a little bit of brazing or something like that, and it catches that stone, the 49 will just, it's brittle. It'll just snap. So I kind of got away from using those, and I went to the J47 or A47s. I got both. The aluminum oxide are a little bit cheaper than the silicon carbide, just a little bit. But anyway, the 47s were less likely to, like if there was a really bad flat spot or something that was down in the bottom of the tube, they'd handle the abuse a little better than a 59. The 59s would break. If I got a tube that doesn't have any imperfections in it, then 59 will work fine on a soft metal tube. But yeah, these are the softest stones I've got, so. They leave a good finish. I'm gonna tell you, this ain't for the faint heart. You gotta love what you do. You're gonna take all the love right out of it. Ooh. I don't know, we may be there. Wow. Yeah, I think we got it. I'm going to run it. The softer stone leaves me a little bit better finish if it's wet. And you do the final run on it. It's really slick, and it I use Dow Corning 77 lube when I lube my compression tubes. It's a really fine grade of molybdenum. It'll embed in some really fine crosshatch. Like right at the very back, and there'll be a little bit of a. Well, that stone is just about gone. Oh yeah, that's a beautiful finish up there. I just hope and pray them flat spots are gone. Alright, I'm going to dry this out and see if I can't get you a good look down there. Here's hoping. All right. Nothing down in there but a reflection from the plug. All right. See at the top of the tube at the bottom. You look down there, if you see anything that looks like an imperfection, it's usually a reflection off the plug. Yeah, that looks good. I don't know if you can see that. I'll be scrubbing on it a while trying to get all of it off, but it's hot. Anyway, I started working on these compression tubes 11:30 last night. Right now it is 6:18 in the morning. So I have not done the final pressing the buttons in and all that, but I buttoned both two compression tubes and buttoned two pistons. Start at 11:30, not taking a break. It's 6:15. I'm still not done. I'm starting to burn out, so I'm going to go ahead and lay down for a little bit. One of these tubes is set up with a standard parachute seal that the customer sent me. The other one I have to build a seal. I'm going to make one a little bit harder so to give a little bit higher output. Anyway, hope you got something out of it. I sure be glad when it's done. Hope you enjoyed watching. Have a good one.